Hello everyone, welcome back to the channel. In this project, I will work on a dataset related to the medical records and patients discharged from a local hospital. The data was obtained back when I was an intern at the records department of a local government hospital in my hometown. There are 6 subunits under the department, and I spent 2 months each in 2 of these subunits, which I will explain later in the video. Due to the confidentiality of the data, I will not be sharing the files like I did in the previous project. However, I will display the results later on in this video. Similar to the previous project, I will use the R programming language as well as libraries such as the Tidyverse library and R Color Brewer in this project. So let's begin. The first step in this project is to load our libraries. And if we haven't installed those libraries yet, we can use this Tools tab here and click on Install Packages and type in the names of the packages or the libraries that we're going to use in this project. In this project, we're going to use 3 packages, specifically dplyr, ggplot2, and rcolor-brewer. dplyr and ggplot2 are contained in one package called the Tidyverse, so we have 2 options whether we want to load these 2 libraries separately like so, or we can just use the Tidyverse package, but let's just use these the first 2 packages as such, and also the rcolor-brewer package. To those who don't know, the dplyr package is a package that contains functions that we can use to manipulate our data. Basically, we're going to use the functions in this package to create new variables and to use some functions on the existing variables to create a new variable. We'll see that later on. For the ggplot2 package, it is a data visualization package where we can plot all sorts of graphs or charts that we want. In this project, we'll mainly use the bar charts and one pie chart to visualize our data. And the third package, rcolor-brewer, contains a set of palettes that we can use to make our plots look more pretty or more interesting. Now we run this code. I've already run these 3 lines of code. So the next step is to import the dataset into our workspace. The first dataset that we'll be working on is the medical records. Here it is referred to as BHT. Honestly, I forgot what BHT actually stands for. I think it's an acronym for something. But in the records department, basically the medical records are referred to as BHT, and it's contained in the data is contained inside a CSV file, which I'm afraid I cannot share since it's actually a confidential data. We'll store this in a variable called BHT. And we'll use the read.csv function to import this data. So if we have a look here, we see that it contains the number of medical records received by the records department based on the wards or the departments in the hospital, and also in each month right here from January to December. What we're going to look now is the number of medical records received by the department based on each month. So as you can see, the number of records are stored in columns of based on each month here, the names, January, February, up until December. So we can use the call sums function perhaps to get the sum of this the sum of the medical records received in each month. But just to make things, quicker or easier, perhaps we can create a function that automatically calculates the sum of medical records in each month, and then we're going to immediately add them to a data frame containing the name, the month, the list of months, and also the total number of records received in each month. So let's create that function now. So let us now create this function. We call it sum call, where we're going to get the summation based on column, and it's a function that takes in one argument, df. And the first step inside the body of our function is to create an empty vector called @sum, and then we're going to use a for loop in the range of number of columns inside this data frame. So call names, the function call names here will list the names of the columns in our data frame, and the length function here will get the number of those columns. So that is why we're setting the range of I to be in starting from 2 until the end of this column. It's for me it's like an easier way, like a cheat way, perhaps, if one could say it like that. A cheat way to get to the end, to know the length of the number of columns, instead of just typing this here. There are 13 columns in our data set, so the range will definitely be from 2 until 13, but if we don't know, we can just use this function right here. Okay, so inside the for loop, we're going to extract the summation using this sum function, and we're going to specify the argument na.rm set to true. na.rm here stands for removing any missing values inside our data set. We're not sure if there are missing values here, but as you can see, if the departments or the wards didn't send in any medical records to the records department, their number will be listed as 0. But just to be safe, we're going to use this na.rm function, and the sum function here obviously will take in a numeric value, so we'll have to remove this first column here, which is the ward names here. So we'll subset the data based on the column using this square bracket function here, and the results will be stored inside x, and then we'll append the value here, the values that we have extracted here, x, to our x_sum vector. So we exit this for loop, and then since we basically here we have already gathered the summation of the medical records in each month, so now what we're going to do is we're going to put them inside a data frame. We'll call this mydf and use the data.frame function to create the data frame, and the first column will contain the month names. For this, we'll put them inside this factor function. Basically, we're creating a factor data type here, and there is a built-in vector inside R called month.abb, the abbreviated names of the month. If we just type this in here, we see it's a vector containing the names of months that has been abbreviated. So we'll put them inside this factor function here and specify that the levels are obviously in monthly order. And the second column inside our inside mydf here is the sum of each month, the sum of the medical records received in each month. And lastly, we'll return this mydf outside of the function. So now we have created this function. Let's use it on our BHT data frame. So we'll put it inside one new data frame, and we'll call it BHT underscore sum, and use this sum call function and run this using the BHT data set that we have imported earlier. So we'll run this function first, and then we'll run this line of code. We'll take a look at the results of our function here in the console, and we see that for example, in the month of January, the records department received 3,225 records altogether. In February, it is this amount, and March is this amount, and so on until December. So in the bar chart that I will be plotting, that we will plot later, I would like to add the percentage of each month, the proportion of the medical records received in each month. So we're going to create a new column using a function under the dplyr package called mutate. To do this, we're going to start by specifying the data set that we will be using here, BHT underscore sum, and using a pipe operator under the dplyr package, we'll pipe this function, mutate the dplyr function, to create a new column called %, and it is actually the value of the values under the sum column multiplied by 100. So this is the proportion of the number of records received in each month. And then we're going to round out this number to 2 decimal places using this round function here, We just run this code here, try to see this inside the console. We see that here we have a new column created, %, and basically in January 8.95% of the total of the records altogether being archived, being sent to the department, belongs in January alone. So that is basically what we're getting over here. So then we save this into our dataset BHT underscore sum, and now we're going to make a bar chart. So using the ggplot function, first we'll specify the dataset that we will be using, and then using the AES function here, we describe the aesthetics, meaning we'll feed in what is our x-axis. In this case, it is the month. The y-axis is the sum, and we're going to fill in each plot based on the x-axis, which is the month. And we're going to create a bar chart, and for this we'll use the geom underscore bar layer, and inside the parentheses we'll have an argument called stat here. And as you can see from this yellow box, it says that the default value for stat is count. However, in a previous video, you see that I explained that what stat equals to count here means is that it will count the number of instances inside our data set. For example, if there is more than one, for example, let's say that we have more than one January here, it will basically just calculate the values of January, meaning that it will see that for example, if there's January 1 here, and then we have another January below December here, that means we have 2 Januaries in our data set, right? So when stat is set to the default value, which is count, it will say that January is equal to 2. However, what we're going to see here is the sum obviously the sum of the medical records received in each month. So we have already specified here that y is set to sum. So therefore, we have to change the default value here from stat equals to count to stat equals to identity. Next, we're going to flip our coordinates. The x-axis will be the y-axis, and vice versa. Next, we're going to remove the background, the gray background. If you're familiar with any ggplots, if we don't add this layer, basically the background will have this gray colored background. So we're going to remove that gray colored background and using this theme underscore minimal layer, and then we're going to remove the legend. We don't need to have a legend box in our plot here. And we're going to use one of the palettes from our color brewer. Here I would like to use a palette called set 3. You can take a look at the color palettes available in our color brewer by googling our color brewer tutorials, and also the link to one of those tutorials in my description box. And not last actually, but we're going to relabel our x-axis to month, our y-axis to, let's say, count, and we'll add a title to our plot. Let's call it records archived. And lastly, like I said, we're going to list down the percentage of those, the proportion of the records in each month by using this geom text layer. And we'll specify the label as %. But just to make it look, for me to make it look more prettier, we're going to paste the strings of % here with a % label, separated with no space at all. And then we're going to position the text so that it will be right in the middle inside of those inside of each of those bars. So we're going to position stack and adjust the location of the text here using this vjust. So let's try to run this function. Okay, sorry, I forgot to run here. And then we're going to run this function. We zoom in on the plot here. So this is our the data set, the BHT_sum data set, and we see here that in January, 8.95% of the records received by the department belongs in January, and 8.28% of the total records sent to the department is in February, and so on. So if you can see here, January is at the bottom while December is at the top. And maybe to some people this wouldn't bother them, but maybe if we can flip this the X labels here so that January can be at the top and December to be at the bottom, that would be great, don't you think? So what we're going to do is we're going to add another layer here called scale X discrete, and we'll specify here the limits where we'll reverse the levels of the month column here. If you recall, we create this month column, and it's in the factor data type. So factors, they have levels, right? So we rearrange the levels inside this month column so that it will be in reverse order. We're not changing the orders inside that data set. We just basically change them inside our plotting function here. If we try to run this once again, zoom in on our plot, and we see that here the month has been reversed. And we also have to make sure that, you know, even the values are reversed here as well, just to be safe. Another set of files that were sent to the department are the X-ray files, the X-ray films, and just like the medical records, they are, I forgot to explain that the medical records that are archived, the data that I obtain here are actually the medical records belonging to patients that have no follow-up appointments at the hospital, meaning that they, basically they received the treatment and the doctors decided that they do not need any further treatment for that, for their for the reason that they are staying in the hospital. So their records are basically sent to be archived here at this sub department here, and they are only obtained or taken out from the archive or from the vaults if, let's say, for example, maybe the patient suddenly had an accident, and since they already have an existing record in the hospital, they have to retrieve it from the archive. So yeah, that's it about the medical records. The same can be said to the X-ray films as well. They belong to the same category as the medical records. For the X-ray films, we're going to again calculate it. We're going to see how many X-ray films that have been archived, that have been received by this subunit of the records department, based on each month. So we'll repeat the entire process that we just did to the medical records and use it on this CSV file. So first we'll load this CSV file here, similar to what we did with the bht.csv file. We're going to import another CSV file here called X-ray, put it inside a variable called X-ray, and it's basically almost similar to the medical records, the BHT data that we have earlier. Instead, this time, instead of 0 being listed as that the wards or department did not send any X-ray films to the department. So basically what the data set here says is NA. So NA values here means that no X-ray films are sent in that month to the records department. We're going to use the sum call function that we have created earlier to calculate the summation in each month, and we'll store this inside a data frame called X-ray sum. And then we're going to once again add a new column where it stores the percentage or the proportion of the records received in each month. And once again, we'll save this inside our original data set. No, not the original data set, but the ones that we're currently using right now. And then we'll plot a bar chart similar to what we did with the medical records earlier. First we'll specify the data set and the aesthetics. Again, similar to what we did earlier. So perhaps maybe we can just copy this, or let's just change this one right here, the one that we already created. So this is the plot. Perhaps we can change the title as well. Let's change the title so that we don't we don't get confused. Called X-ray films archived. Okay, so this is our plot here. We see that in January received the highest number of X-ray films being archived or received by this subunit, and in December it is the least. It received the least. It's like I said in the intro of this video, where the duration of my internship ends 2 weeks after December. So basically the December data is not exactly complete. The others are collected from the first day until the end of the first day of the month until the end of the month. For example, in November, the number of X-ray films are received from the 1st of November until the 30th, but in December it is until the 20th of December, the data that I have obtained here. So yeah, that explains why the December, if you see later, for now and also for the later plots, you see that December contains the least amount of values, because yeah, like I said, my internship ends in the middle of December. I forgot to mention that throughout my internship I spent 4 months for my internship in here, and the first 2 months is spent at the first sub department, which is called the record general records, if translated directly into English. So basically the records that are sent here is, like I said, the records belonging to patients that have no follow-up treatments. After 2 months at that sub-department, I moved to another sub-department called the statistics sub-department. And in this sub-department, my main job basically just to type in the records or the other basic information of the patients that have been discharged into the data warehouse belonging to the Ministry of Health. And so with the permission from my supervisors, I obtained the data in the first sub-department, I obtained the data related to the medical records and also the X-ray films. For the second sub-department, I obtained the data related to the number of patients being discharged in each month. So basically, what we've done so far is look into the first, let's say like the first subsection of the report that I have to submit to my university supervisor. The first subsection involves the tasks that I handle while working in the first sub-department, and the second subsection is the tasks that I've conducted while under this second sub-department. So here in this second subsection, or basically the next part of this project here, we're going to look at the number of patients discharged based on 3 categories. I separated them into 3 categories. First is gender. Second is the reason for discharge or the type of discharge. And the third one is based on age group. First, we're going to take a look at the number of patients being discharged based on gender, and they are actually stored they are stored inside a CSV file which I call discharge gender. And we're going to first import it, and we'll save this. Let's just call this gender. We'll import this CSV file here. We'll try to have a look. So it has 3 columns. First is month, obviously containing the months in 1 year. Second is the column called male, and third column is female. Male and female are the columns containing the number of patients discharged based on obviously gender in each month here. So we're going to calculate the summation in each month, and for this we'll use a function, a built-in function in R called call sums, where we'll get the summation of the male and female columns. The call sums take in numeric values, so we have to subset the data here, where we'll select only the second and the third column of this gender, this gender data here. This is the second column and the third column here, and as you can see we have NA values, so we have to specify the argument NA, the RM equals to true. We run this and we see that the male column has been summed up, and we see that 19,830 patients that are discharged are male, and the rest here is female. So we're going to save this inside the variable called gender sum, and we'll convert this gender sum variable into a data frame. We'll call it gender df, and one way we can do this is by using this s.data.frame function here. Sorry, forgot to run this first. If we take a look at gender df, we see that the index names here are male and female, and the column name here is gender underscore sum. So let's rename the column. To do this, we'll use the names function here. We'll see names of gender df. The names function here basically states the names of the columns inside our data set, inside our data frame here. In this case, gender df is a data frame with only one column, and it is called gender sum. And we're going to rename this gender sum column into something else, say total discharge. If we run this and we run gender df once again, we see that the name of the column has been changed. Again, we're going to display the percentage of the discharge based on gender, and for that we're going to once again use the mutate function to create this new column here. Perhaps let's not round it up for now. So to calculate the percentage, obviously we're going to divide the values under the total discharge column here to the summation of those values, and we'll multiply it by 100. Well, let's add another column here called gender, and basically it contains the index values for our data set here. So that is why we're using the row names function here, gender df. If we see row names of gender df, we see that it's male and female. So we're going to add this new column here and remove, sorry, we don't have to remove, but to me it's just to make it, is simpler so that we can plot our data later on. The last thing that I would like to do is to rearrange the columns so that they are in the order of the name of the gender here, male and female, the total discharge, and the percentage or the proportion here. If we run this, and we see that this is our data frame here, gender, male and female, total discharge based on gender, and the percentage or the proportion of that discharge patients. we'll save this back inside our gender DF data. So now we can begin plotting. This time we're going to plot a pie chart. So for that, first we'll use the ggplot function here and specify the data set as well as what we're going to put on the x and the y axis. So to create this pie chart, the x has to be this empty quotation marks, empty string here. Y is the percentage, and we're going to fill in based on gender. So next is we're going to add a layer, the geobar layer here. Stat set to identity again because we're providing the y values here, and we also have to specify width is equal to 1. Next is the cohort polar function y, and we're going to remove the gray background using the theme minimal layer. And let's remove any ticks or labels inside our plot. And then we're going to add the percent. We're going to add labels on the pie chart of the percentage of those patients being discharged. We'll use the geom text. Again, we'll use the geom text layer here. And for now, we're going to paste. We're going to paste them. And let's round up our proportion here to 2 decimal places. And we'll paste the percentage value with this percentage sign. And again, we'll position the labels so that they are located in the middle of each bar. We'll add a guides layer here. And add other labels, but in this case we'll remove any x or y labels here. Basically we'll remove any labels on the x-axis or the y-axis. We'll rename the legend box as gender colon here, and we'll add a title to our plot. Let's say patients discharge, and we'll add a subtitle based on gender. And lastly, let's use a palette from the R-Color Brewer library. And this time we'll try to use a palette called Dark 2. So let's try to run this code. And this is our pie chart here. Patients discharged based on gender, and we see that 38.96% of the patients being discharged are male and 61.04% of the patients discharged are female. Next, we're going to look at the patients discharged based on the reason, the type of discharge or the reason that they're being discharged. In the data that is contained here, first let's import the data set and put it inside a variable called discharge. Okay, so in this discharge type.csv file, we see that we have 4 columns. The first column contains the month that the patients are discharged. Second column is the age group, which we will see later on, and then there's the outcome here. In the system that records this patient's discharge, this is called outcome. So that is why this column is named outcome, and basically they contain the type of discharge, the reason for that patients to be discharged. Not really reason, but more like the type. Yeah, the type of discharge. So home here stands for they basically are cleared to go, cleared to leave the hospital by the medical professionals, by the medical officers. Death obviously means that the patient has died. Abscond, abscond here means that the patient left the hospital basically without the permission from the medical officers. DAMA, actually DAMA here means discharge against medical advice, meaning that perhaps the medical officer wouldn't advise the patients to be discharged. However, they insisted on wanting to leave the hospital, so yeah, they have no choice but to allow this patient to be released. I guess that is what here DAMA means. And lastly is transfer, meaning that the patient is being transferred to a different hospital. And lastly, the last column here is count. So obviously it contains the value of the patients being discharged based on the age group and also the type of discharge here. Another way that we can have, since we're going to look at the type of discharge, one way that we can look at the type of discharge available inside our dataset here is using this unique function, and we'll specify the column that we're going to look at, this outcome column here from the discharge variable. So we see that there are 5 unique values here under the outcome column. It is, like I said earlier, home, death, abscond, DAMA, and transfer. Now we're going to calculate the summation of the patients being discharged based on the type of discharge that is listed in their data. And for this, let's try to create one function that we can apply just once on this list of outcomes here. Let's call our function count.discharge, and it will take one value of one argument called type, meaning we'll specify the type of discharge here, which we will pass on to the filter function. So we'll specify that we're using the discharge data set here, and we're going to filter our data, meaning we're going to subset our data where the outcome is equal to the type that we have specified earlier as our input. And then using the summarize function, we'll count the summation of the patient's discharge based on those type. We're going to use the sum function, the built-in sum function under R, and again we'll specify NA.rm set to true just to be safe. And lastly, we'll convert the results here into a numeric format. We'll run this function here first. The next thing that we're going to do is create a vector containing this list of type of discharge here that we have seen earlier. We'll call this vector types, and it contains the unique values of the outcome column. The outcome column under the discharge data frame, and we'll convert it into a vector format by using this s.vector function here. And lastly, we're going to use the sapply function, where we'll apply the function of that we created earlier, count.discharge, on our vector types here. So sapply is like a loop. It will apply our function here on this vector on a loop, and then the results will come out either in a data frame format or a matrix format. So if we run this only, and we'll see here that it comes up, for sapply it will come out as a vector format here. So this is actually a vector but contains names. They're exactly like column names, but they're not exactly columns either. This is actually a vector. The outcome of the sapply function here is a vector, and we'll save this inside a variable called types.count. And using the types.count function, we're going to calculate the percentage of the patients being discharged in each category here. Let's save this inside a variable called types.percent, and we're going to run this value into two digits here. So to calculate the percentage, again, we'll get the values of types.count and divide them, each of them, to the summation of those values under that vector here, and multiply it by 100. Forgot to run this. So next, we're going to create a data frame to save all these three variables here that we have just created. Type here, specifying the type of discharge, and the values from the types variable. Count column contains the values of those patients being discharged, and the percent column is the percentage. For the index names, let's just simply rename it into just value numbers here. So this is our data frame that we're going to create and save it inside discharge type here. So now we can begin plotting. Again, we'll create just a simple bar plot, ggplot, discharge type, and the aesthetics, which is type, and x is type, y is count, and we're going to fill in each bar based on type. Again, geo bar, and again stat identity, and again we're going to flip the coordinates here. Let's remove the legend title, the legend box at the side of our plot here, and we'll use a palette from the ArtColor function, ArtColor Brewer package. For this, I'm going to use this palette called set2, and we're going to add the percentage labels. And again, we're going to position them so that they are in the middle of each of those plots. Lastly, we'll relabel the x-axis to reason for discharge, the y-axis label to number of discharges, and we'll add a title, patients, discharge, and a subtitle based on discharge type. Let's run this function to see if our plot is successful or not. Okay, so we'll zoom in on our plot here. We see that the main reason for discharge by for those patients is that they're allowed to be discharged. They're allowed to go home by the medical officers, meaning that they are considered as, okay to be released from the hospital. And thankfully there's not so many patients who are so secretive about the fact that they're leaving the hospital without letting any medical professionals know that they are leaving here. And death, the reason for discharge under the death category, meaning that the patient has died, is the second most popular, we can say, the most popular reason for discharge here. It's not popular, it's quite a morbid joke, but basically what I'm trying to say here is that other than the fact that the patients are allowed to go home, the other main reason for the patients being let go by the hospital is the fact that they have died. So now, for the final part of this project is to see the patient's discharge based on the age group. Once again, if we take a look at our discharge data, we see that in the first 5 rows, here we see, but the first 5 rows containing data of the age group LT 28 days. LT 28 days stands for less than 28 days, meaning the patient belongs in that age group. Obviously, is aged less than 28 days. The patients are newborn babies. If we want to take a closer look at the unique age groups, again, we can use this unique function and specify the column that we're going to look at, and we see that the values are LT 28 days, which as I have just explained earlier, stands for less than 28 days. The next age group is 29 until 364 days. Again, newborn babies, but they're aged 29 days old. And then toddlers, 1 to 4 years old, little children, 5 to 14 years old, children until preteens, basically. Teenagers, 15 to 24 years, young adults, 25 to 34 years, adults, 35 to 44, 45 to 54, 55 to 64 years old, senior citizens, 65 to 74 years old, and lastly, MT, 75 years, which stands for more than 75 years old. Again, let's try to use a function that we created earlier, similar to what we created earlier here, count discharge, to select only patients based on those age groups, each age group, and then we're going to summarize them by calculating the total patients being discharged based on those age groups, and lastly to convert them into numeric format. So perhaps we can copy this function and rename it. Let's just simply rename it as count.discharge2, and it will take in one argument. Here, let's just call it age.group, and we're going to filter under the age group column, where it is set equal to the values that we have provided in the input of our function here, and we're not going to change anything else. Similar to what we did earlier for the type of discharge, we're going to create a vector containing this list of age groups here. We'll just simply call it age groups. This time we're going to put them as we're going to create them as a factor data type. And let's rearrange the levels. If we see, try to see age groups here, we see that the levels, they begin by 1 to 4 years old. We actually want to begin with LT, less than 28 days old, because actually that is the youngest age group that we have. So we're going to re-level, we're going to change the levels of this age group here by first storing them inside these levels, age.groups. And inside C here, we'll just copy all this and paste them. Make sure that each of these is contained inside double quotation, or perhaps inside quotation marks. We'll run the function here, and once again, if we take a look at age.groups, we see that the levels here have been changed. The order of the values has been changed according to what we have specified earlier here. And now we're going to use the asApply function on the age.groups the age.groups variable here, where we'll apply the function count.discharge2 and save them inside a data frame, into a vector, simply just called total age group. Again, we're going to find the percentage of the discharge based on each age group, and we're going to round it up into 2 digits, 2 decimal places. And the percentage are basically the values of total age group divided by the summation of the values under this vector here, and multiply it by 100. We'll save this into a variable called age.percent, and we're going to create a data frame simply called discharge age data.frame, and the first column is the age group, the names of the age group. Second column is the values or the summation of the patients being discharged based on each age group. Percent is the percentage, and again, we're going to relabel the index as simply from 1 until the length of the age groups vector. If we look at this data set that we have just created, this is the data set that we have just created. Now again, we're going to make a simple bar chart. ggplot discharge age and the aesthetics. X is age group, Y is count, and we're going to color based on age group. We'll add the geomobile layer, stat set to identity. Again, we'll flip the coordinates, and as we've seen earlier, for the medical records visualization and also for the X-ray films visualization, perhaps we can but to make it look easier, we have to flip the orders of the age group. If we don't specify the scale as discrete layer here for our age group data, just like what we've seen earlier, the first level of the age group factor, which is the less than 28 days old patients. They will be at the bottom of the plot. So for me, I would like to prefer it if the first level is to be located at the top. So I'm going to reverse the orders here in our plot. Sorry, age group, and then I'm going to add labels inside each of those plots. Basically, it's the percentage of those patients being discharged. This time I'm also going to remove the legend box and use a palette. Again, I'm going to use the palette called Set 3. One thing I would like to remind when using the color palettes from our color brewer, make sure that the number of bars, in this case we're plotting a bar chart here, make sure that the number of bars and they are actually less than or equal to the number of colors contained in each palette of the Art Color Brewer package. So for example, in this Set 3 palette here, they contain, if I'm not mistaken, 12 colors, and we have to make sure that the bars that we're going to plot here are less than or equal to 12, meaning that if there are more than 12 bars, they will not be displayed in our plot. Here you will get a warning message inside the console saying that the number of bars exceeds the number of colors contained in the palette. So here, the age group, we see that there are 11 age groups here. So Set 3 has 12 colors. So yeah, it's safe for us to use this color palette. And lastly, we'll add some labels. First, let's relabel the x-axis to age groups and the y-axis to number of discharges. We'll add a title to our plot here. Again, patients discharged, and a subtitle based on age group. We run this and zoom on our plot here. We see here that the age group of 25 to 34 years old has the highest number of patients discharged, meaning the patients that are discharged, they're mostly between the ages of 25 to 34 years old, and the patients being discharged, for the least proportion of patients discharged are, babies between the ages of 29 until 364 days. So basically, this is the end of this project. If you enjoyed this video or you might have learned something new from this, please give this video a thumbs up and subscribe to my channel for more contents like this in the future. Thanks for watching.